Alright, welcome back. In this video, the objective is to be able to identify and apply the distributive property of multiplication over addition or subtraction. And so, before we start, I'd like to just review a couple terms that you should know and be familiar with and we'll be using in this discussion. And so, well, first off, we have what's called constants. Those are just regular numbers. We also have variables. Those would be almost any letter we can use as a variable. And then sometimes we have these combined together where a constant is being multiplied by a variable, and it looks like 3x or 6b and so on. And in this case, all of these are called terms. And constants can be a term, variables can be a term, and these are also terms, and the number that's being multiplied by the variable, that's called the coefficient. Now, we know that, I think you've studied before about like terms. So if you have two constants, 3 plus 4, for example, that would be 7. Those are like terms. Those are both constants, and we can do that problem. Now, we cannot, however, add a constant plus a variable. These are not like terms, and so we cannot do that. By way of one more example, if we have some terms like this where we have 2b plus 3b, well, we can do that and get 5b. That's okay because these are like terms. They both have the same variable to the same power and so on. So we already learned PEMDAS, and please excuse my dear Aunt Sally, parentheses, exponents, and multiplication, division are together, and addition and subtraction are together from left to right. However, today we're studying something called the distributive property, and that helps us be able to solve problems a little further, especially when we have items inside the parentheses that are not like terms. So let me give you a few examples of this. Let's say we had, let's say we have 2 times 3 plus x. Now we know that 3 is a constant, x is a variable, so those are not like terms, so we cannot just add those together inside the parentheses. We don't know what x is. We might be able to find that out later, but for right now, we can't add those together. They're not like terms. However, we have this 2 being multiplied by the total of 3 plus x. So what we're saying is we have a 3 plus x and another 3 plus x, so we have 2 of them. Okay, so instead of doing this, we can also see that this becomes 3 plus 3 is a total of 6, and x plus x is how many x's? That's 2 x's. So instead of doing it all this way, and this wasn't too bad because it was a 2 in the front and not some bigger number, another way to do that is this. We simply distribute, distribute means distribute the handouts, distribute the worksheets, that means pass it out, right? We're going to distribute that 2 into the first term of 3. So we can do, this is 2 being multiplied the total of 3 plus x, so we can do 2 times 3 and get 6. And then we can do, secondly, 2 times x, and that will give us 2x. And you'll notice that I intentionally have the same operation here of addition. So 2 times 3 is 6, 2 times x is 2x. They were being added together here, so we get the same here. You can do this for addition, And you can do this if there's subtraction in the middle. Let's do another example. Okay, I trust that all of you guys are taking good Cornell notes with key terms on the left, examples on the right, definitions. We already went over a few of those. Let's do one more example here, or maybe two more examples, I suppose. Let's say we had 3, and then we can put the variable first, t plus 5. Well, again, we're multiplying the 3 times the total of 2 plus 5. That means we would have 2 plus 5, 2 plus 5, 2 plus 5. Since we can use the distributive property, we don't need to do that. We can simply do 3 times t gives us 3t, and 3 times 5 gives us 15, and the operation was addition. Now let's do a few with the negative here maybe. What if we had 6 times 2 minus, let's do s. Got to be very clear to make that s not look like a 5. There we go. Okay, so 6 times 2 is going to be 12. Now, 6 times, we know from doing integers that whenever we have subtraction here, we usually want to add the opposite. So we could do that again as well here if we wanted to. So we could make this plus, if we suppose, I suppose. And then now we have the 6 times negative s. Negative s. So that's going to be negative 6s. Now, was that adding the opposite necessary? Maybe, maybe not. 12 minus 6s would also give us the same answer. Now, it can get a little tricky, and I'll just do one more. Let's say we have negative 4 times, let's do b minus 7. Okay. Again, these variables can be interchangeable. Sometimes the constant first, sometimes the variables first. Negative 4 times b, have to be careful, negative 4 times b gives us negative 4b. And then if you wanted to add the opposite again, which would be fine, then you have negative 4 times negative 7. And we know that negative times a negative is a positive, and this was the addition here, so we have negative 4b plus positive 28, because again there was a negative 4 times negative 7. So for some people it helps to kind of keep track of it if you put this in parentheses. You don't have to, but it's up to you if that helps you, distinguish what's what. All right, so your summary for this lesson, I suppose, is to use the distributive property of multiplication. Make sure you multiply the number or the term in front of the parentheses times each of the inside terms, and make sure you're very careful with the signs. The signs is usually where people get hung up on. So that could be your summary. And just as one final note, we've already mentioned, sometimes here's a negative, sometimes there's a negative here, sometimes there's a negative here. You need to make sure that you keep track of all those as well. All right, that's it for this video. Thank you for watching.